Hello everyone, welcome to CleanCode. Today we will be solving problem remove k digits, and the problem states that we have given a string number and that represent non-negative integer and an integer k, and what we have to return is we have to return the smallest possible integer after k removals. Okay, so let us go to the whiteboard and deep dive like how to approach this problem. So yeah, we have num as 1, 4, 3, 2, 2, 1, 9, and k as 3. So how to approach this problem? One solution what we can do is like we can maintain a stack. We can maintain a stack, and the stack will be maintained in increasing order. Increasing order stack. So yeah, let us see how we will be maintaining that. Okay, we have 1, 4, 3, 2, 2, 1, 9, and we have k as 3. K as 3. So first of all, one will go in the stack. Then we will be sending 4. So we will be sending 4 in the stack. And since this is increasing order, nothing will happen to the stack. Again, when we move 3 here, 3 here, when we are moving 3 here, we can see that 4 is greater than 3. And this is like exploiting our increasing order sequence. What we can do is we can remove 4 this 4 from here when we have 1 and we have removed 4 from here. Then we will be checking that whether 1 is greater than 3. It is not greater, so yeah, we will be adding 3 here. So now again the increasing order of the stack is maintained. Then we have 2, and yeah, and also we have deleted one of the element, that is 4. The k value will be changed from 3 to 2. Okay, then we will be having 2 as the element. Then before inserting 2, we will be checking that whether this element is greater than 2. Yeah, this is greater than 2, so we will be removing this. So we will be removing this. So after the removal, we will check whether 2 is greater than 1. Yeah, this is true, and so we will be inserting 2 here, and again the increasing order is maintained. So we have inserted 2 here. Now then, again, we have deleted 3 as one of the element, so we will be changing k value as 1. Now then, what we have? We have 2 again here. We have 2 again here. So we will be pushing 2 here. We will be pushing 2 here in this particular stack. So after pushing, we will be getting 1, then 2, and then 2. Then again, 1 will be pushed. So yeah, before pushing one, when we are gonna push one, we are checking whether this is greater than one, and this is exploiting our increasing order. Yeah, this is exploiting our increasing order. So this stack we will remove 2 from here. So we will be having 1, then 2, then again we have encountered 2. But can we remove this? Can we remove this? Because previously when we removed 2 from the stack, the value went from 1 to 0. Now we don't have any of the power to remove any more element. So we will be inserting 1 here, and similarly after 1 we will be pushing 9, and hence this is the smallest number which we can obtain from the k deletions of the character. Okay, got it. So this is the first approach that we can use. This is the first approach. And also in this approach, we have to we have to we have to make sure there are there are no leading zeros. No leading zeros. Okay, there are no leading zeros. So how we can do is like we can iterate until we find 0. Like if this is 0 0 0 and this is 1, so we have to stop at this. We can store this particular address in some variable, and we can start the substring from here to the end, we can get that particular answer. So this constraint we need to have in our mind to maintain this particular correct solution, to get the correct solution. Okay. And also, what is the other thing? What is the other thing that we should keep in mind is like if this is in increasing order and we have given as k as 2, our stack will be like 1 will be inserted, then 2 will be inserted, then 3 will be inserted, then 4 will be inserted, then 5 will be inserted. Okay, then 5 will be inserted. Our k value is not exhausted till now. Till now, we have not exhausted any k value. Now, what we can do is like we know that this is done in increasing because we are maintaining an increasing stack. So this we can remove these two characters, these two last, because this will be the maximum. So we will be removing these two last as the k value is 2. If the k value was 3, we will be removing this last three characters. So that we can get the particular optimal result. So this is one of the solution that comes in my mind. And there is one more solution which act just like this, but the space complexity of this is O of n, and O of n, and also the time complexity is order of n, because we are using stack and we are pushing the element in one iteration only. Okay, so this is one of the solution, and instead of stack we can also use string builder. Okay, we can use string builder instead of stack, and we will be populating the string answer here itself only. So yeah, so the this space complexity will be reduced to O of n. So yeah, let's start with the coding part. What we have to do is we have to have one string builder. Let us rename this as answer. Then we can have one n as the length of the num. Okay. Then what need to do, we need to iterate through this and we have to populate our string builder in increasing order of the digit. But till when? Till when we can do that? We can do that until my k is greater than 0, and we have to check whether this is not empty, because we have to find the last element from this, and we have to check whether this is greater. If this is greater, then we have to like pop this particular element. Pop this particular element. This is caret my answer dot length minus 1. If this is my greater than num dot char at I, we have to remove this. We have to remove this. How we can remove this? We can just remove by setting the length as 1 minus the original length. Answer dot length minus 1. Okay, perfect, fine. K minus minus has to be done, and we have, else if this is not happening, then we can append all the elements here. Num dot caret I. Okay. Now the second part. What was the second part? The second part was if there is any k remaining, we have to use that. How we can have like 1, 2, 3, 4, 5, if this is the number and k is 3 as we discussed, then we will be having 1, 2, 3, 4, 5 as in our string builder, but we have 3 to exploit. So we can do and we can remove 3 elements and 12 will be the minimum. Okay, we have to do this. So let us see how we can do. We can have as answer dot set length, and we can do answer dot length minus k. So whether will this work? Yeah, but in case when k is greater than answer dot length, it will be returning a negative value, and this will be not good for us. This will result in exception. Correct? So we can do is we can have this. Okay, got it. So this part is gone now. We don't want to have this, and the next part was the next part was eliminate if any leading zeros are there. Okay, so yeah, we have one start. Let us take one start, and we can check whether the start is less than answer dot length. Okay, and whether my answer dot char at my start. If this is equal 0, we can proceed with the loop. Correct? We can proceed with the loop. We have to increment. We have to start. We have to start like if this is the thing. We have to start from here. We'll going until we found any non-zero element. So our start will be pointing here. This will be the start position. So let us leverage this start, and how we have to return the answer as if my answer dot substring my start, because we have to eliminate the zero. If this is there, if this is there, we have to check whether this is empty. If this is empty, we have to return zero, and if it is not, then we can just return this itself. Okay, perfect. Let us run the code. Yeah, the code is working fine. Let us submit it. Let us hope that the submission is successful. And yeah, we can see that the submission is good. The answer is correct. And yeah, guys, if you have any doubts, any kind of doubt, any problem you want me to solve, then you can just write in the comment section. And thanks for the support. Like, subscribe, and comment.